Hi everyone, in this video we will be going over square and cube roots. Our essential question for today is, how are square and cube roots simplified and used to solve complex problems? So once again, how are square and cube roots simplified and used to solve complex problems? So first let's go over the definition and some examples of square and cube roots. So the definition of a square root is a number whose value can be multiplied by itself to give the original number. Okay, so once again, a number that can be multiplied by itself to give the original number. So for instance, if you think about the square root of 9, you have to find a number that can be multiplied by itself to give 9. So for instance, 3 times 3 is 9. So that means the square root of 9 would be 3, because again, 3 times 3 is 9. Now let's think about that in a like a physical way. So think about a cube or a square that has 9 grids. So you've got 3 and 3 on each side. So this is our length, okay, and this is our width. You've kind of got like 2 dimensions in this square. Well, if you're trying to find the area of this square, you just multiply it, right? And what's 3 times 3? That is 9 square units, okay? So if you were ever trying to find the length of a square, you could use the square root application, because you just find the square root of it, because the length of a perfect square, they're always going to have 2 sides that are exactly the same. And that's where that square units come from, okay? Because we're talking about a square. If you were to think about a 4, if you had 4 on each side, that'd be 4 times 4, and that's 16 square units. So the square root of 16 would be 4. So whenever you're talking about square units, the reason you're thinking of that is because the fact that square root of 9, the answer is 3, and 3 gives us the length of both of those sides. All right, so let's look at some simple examples. So the square root of 25 is a number that can be multiplied by itself twice. And we know that 5 times 5 is 25, so the square root of 25 is simply 5. So let's look at another one. What about the square root of 0.49? Now, although this kind of looks scary, really just try to figure out, well, first, what's the square root of 49? Okay, and the square root of 49 we know would be 7. Okay, so the square root of 49 would be 7. But we need that to be some sort of decimal so that it can be the solution to the square root of 0.49. So always start with just putting it as 0.7. And think about if you had 0.7 times 0.7, would your decimal be in the right place? Okay, so 0.7 times 0.7 is 49, and I have to move my decimal over 1 and 2 places, which makes this perfect. So that looks just like square root of 0.49. So we know then that our answer is going to be 0.7. All right, what about one with a fraction? Although it looks like it's difficult, really you're just saying, okay, what's the square root of 1? And what's the square root of 36? Okay. Well, the square root of 1, what times what makes 1? Well, that's just 1, because 1 times 1 is 1. And the square root of 36 would just be 6. So that means your answer then is just 1 over 6. You just break that fraction up, and then you solve it. All right, and then what about one that has a negative on the outside? Well, first find out what's the square root of 400. Okay, so 20 times 20 is 400. And since that negative is on the outside, then it just stays on the outside. And just stays a negative 20. So pretty easy. All right, let's talk about cube roots. Now, a cube root of a number is a value when cubed or multiplied by itself 3 times gives you the original number. So for instance, on this one, the cube root of 8, you need to think of a number that can be multiplied by itself 3 times and give you 8. And that number would be 2, because 2 times 2 times 2 is 8. Now let's think about this like we did earlier. Before we talked about a square when it was square roots, now we're talking about a cube because it's cube roots. And if I had a cube, and let's say all the sides were 2, that means I've got a width, I've got a length, and I've got a height. So before I was talking about length and width, in a square, but now with a cube, we add that extra dimension in of a height. And so that gives us 3 dimensions, and that's where we get that 3 right here. Okay? So in this example, to find the volume, you just do 2 times 2 times 2, which is 8. And you can see that kind of relates to what we were doing over here. Okay? So if I was to find the cube root of 8, that gives me 2, because 2 times 2 times 2 is 8. And that relates to cubed roots. And so when you're talking about squares, envision that you're making a perfect square. And when you're talking about cube roots, envision that you're making a perfect cubed. Okay, so let's look at some examples. So first example, what's the cube root of 64? Well, that's a number that can be multiplied by itself 3 times. So that would be 4, because 4 times 4 times 4 is 64. Okay, now let's think about this cubed root of 0.027. Well, again, remember like we did earlier, just find the cube root of 27, which is going to be 3. Now, just put a decimal right in front of the 0.3, and let's check and see if that one works first. So if I did 0.3 times 0.3, that gives me 9, and then I have to move the decimal over once and twice. So once and twice. And if I took that number, so 0.09, and I multiplied that by 0.3, I get 27. And I have to move the decimal over 1 and 2 and 3. So 1, 2, and 3, which just makes that perfect. Okay? So our answer for the square or the cube root of 0.027 would be 0.3. Now again, let's think about 1 with a fraction. Instead of doing this all together, you can just break it up. So I find the cube root of 8, and I need to find the cube root of 125. So I'm kind of just separating those to make it a little bit easier. Now, earlier we found out the cube root of 8 is 2, so that goes in our numerator. And then we have to think what number times itself 3 times gives us 125. And 5 times 5 times 5 is 125, so the cube root of 125 is 5, which means our answer is just 2 over 5. All right, last one on this page. So what about when we've got a negative on the outside again? So you have to think, what is that number times itself 3 times? That gives us 1,000. And that number is 10. And since the negative is on the outside, that gives us a negative 10. Now let's look at a few more advanced problems. So although this looks scary, it's really not. The best way to solve these problems is to break them up. So break it up into the square root of 4, the square root of x squared, and the square root of y to the 4th. Now that first one is easy, right? Because we all know that the square root of 4 is just going to be 2. I'm just going to write that over there. We know that. That one's simple. But when you come to these ones with variables, all you need to think about is how many pairs of 2 are in here. So for instance, if I was to separate this one, I would have, that's basically saying the same thing as x times x, right? And how many pairs of x's, of 2 x's are there? Well, there's just one pair of x, so that just gives me x. Think about this, that makes sense, right? If I was to do the same thing with 4, to get to 4, I have 2 times 2. So there's one pair of 2, which gives us our 2 down here. All right. Now what about y? When we break that down, there's 4 y's in there. So I've got y times y times y and times y. I've got a pair of 2 here, and I've got a pair of 2 here. And I have to use 2 because remember, square root, you're talking about basically finding it's like the 2 there instead of the 3 with the cube roots. Okay. So I've got 2 pairs of 2 y's. That gives me y to the 2nd. Now, a really quick shortcut on it that you can use, but I think it's important to understand this down here, is since this is kind of like having a 2 right here instead of the 3 with the cube roots, what's 2 divided by 2? Well, that is just 1, which just gives me an x. And over here with the y's, what's 4 divided by 2? Well, that is 2. So that's where I get my y to the 2nd as well. So that's a little bit of a quicker way to think about it if you can't just naturally see that on your own. Okay, so then what that means is our answer is just going to be 2x y to the second. Let's try another one. What if we had the square root of 36 x to the fourth y to the 12th? Well, start with just 36. The square root of 36 is 6. Okay, how many pairs of x, when we look at x to the fourth, how many pairs of 2 are in there? Well, we know that there would be 2 pairs. So one set of, one set of 2 x's and a second set of 2 x's, which gives us x to the second. Or again, you could just do 4 divided by 2, and that gives you 2. Now think about the y. Okay, if I was to break down all those y's into groups of 2, that would give me 6 groups of 2, which means I've got y to the 6th. Or again, you could say, okay, 12 divided by 2, which is the square, is 6. So that's our answer. All right, let's keep practicing some of these. Now this time we've got a cube root, so that's a little bit different. So the cube root of 8 we know is going to be 2, because 2 times 2 times 2 is 8. Now instead of thinking about groups of 2 this time, you need to think about groups of 3. So on x to the third, you're talking about, again, an x times x times x. And you've only got one group of 3. So that means the cube root of x cubed is just x. Now with 9, I'm not going to write out all those 9s because that's just crazy. We've got y to the 9th, and how many groups of 3 does that make? Well, that makes 3 groups of 3, so I get y to the 3rd. And just like before, a quick kind of cheat is that you could say, okay, what's 3 divided by 3? Well, that is going to be 1, which we just don't write the 1 as an exponent. And 9 divided by 3 is 3, which gives us that y to the 3rd. All right, let's look at one more cubed root example. All right, so this time we need to find the cube root of 125x to the 12th y to the 18th. Now I know the cube root of 125 is just 5, so that's pretty easy. And then think about x to the 12th. How many groups of 3 are there within that cube root? Well, again, you could just use the cheat and go 12 divided by 3 is 4, so I've got x to the 4th. And if we want to use the cheat on this one as well, 18 divided by 3 is 6, so I get y to the 6th. And that's just talking about how many groups of x's and y's are within that cubed root. All right, you've got a few problems right now to try on your own, so try those and make sure you input those answers into Edpuzzle. All right, now we're going to talk about solving equations with roots. Now, the first thing you need to do is think back to solving equations. And remember that you need to do the inverse property to both sides of the equation. The same applies to these types of problems, except now you're dealing with square roots. So for instance, think about x squared equals 36. Okay, what's the inverse of a square? Well, the inverse of a square is a square root. So to be able to get x by itself, you have to find the square root of both sides. Now think about that. Remember earlier when we were just simplifying those problems? If we had x to the second, how many groups of 2 are within there? Well, that's just 1. So when I simplify that, that just becomes x. And when we're solving equations, our goal is to just get the variable by itself. So by square rooting both sides, we get x by itself, and we find out x equals 6. So it's actually a really easy process. It's way easier than those really advanced multi-step equations we've been doing. All right, so let's look at a couple examples. So if I wanted to find what x is, all I have to do is I just have to find the square root of both sides to get the variable by itself. So by finding the square root of both sides, x is now alone, and the square root of 64 is going to be 8. Same thing, or very similar on this side. However, you've got this 2 here, which tricks a lot of people. Okay, so before you even begin to solve this equation by using square roots, you need to get rid of that x first, or that 2 first in front of the x. And think about that. Think back to solving equations. This is multiplication right here, right? So 2 times x squared equals 18. We want that 2 to go away so that we're just left with the x squared. So the inverse operation of multiplying by 2 would be to divide by 2. And when I do that, these are going to cancel out, and I'm left with x squared equals 9. And now that looks much more like a problem that we're used to seeing over these last few examples that we can solve. So to get x by itself, we need to find the square root of both of those, and that gives us x equals 3. But it's really important on this problem to remember first that you need to get rid of that coefficient in front of the variable, because if not, you really can't easily find the square root of that, and it wouldn't work anyways. All right, let's look at some with cube roots. So we do the same thing as we did with square roots, except this time we're finding the cube root of both sides so that x will become by itself. And that for some reason wasn't written there, but I'll write that in. Okay, so the cube root of x cubed is just x, and the cube root of 343 would be 7. So it's pretty much the exact same thing we've been doing through these whole entire notes, except it's just a little bit, it's just written with an equation really, so just a little bit different. Now, similar to the last problem, we have to get rid of that coefficient with the 5 first. And to do that, we have to do the inverse operation, which is dividing. So we divide by 5 on both sides. And when I do that, these cancel out, and I'm left with x cubed equals 8. Now, what we have to do now is we have to find the cube root of both sides. So the cube root of both sides, and that is going to give us x equals 2. So x equals 2. All right, you've got a couple practice problems to try. Try those problems and then put your answers into Edpuzzle. All right, last set, a couple word problems to look at. So it says Mrs. Kelly's classroom is 225 square feet. What's really important to notice here is that it says square feet. Okay. What is the length and width, so length and width of the classroom if it is in the shape of a square? So you're thinking about, okay, I've got the square classroom, and if it's a square, that means this side is the same as this side, because the length and the width have to be the same in a square. Because if it was 5 and 3, that's not a square anymore, that's a rectangle. Now, the best way to do this is you can just create an equation, and you can say, okay, well, I know that x and x are going to be my length, which is saying x times x, which is x squared. So I know that whatever x is squared is going to give me 225. Okay, because again, let me just really reiterate that, is that x and x, when you find area, they're being multiplied, right? And so x times x is the same as x squared. So all we're saying is that whatever x is squared is going to give us 225, because we know the lengths and the widths are the same. So to solve this, we just find the square root of each side, and I get x equals 15. So I know the length and the width would be 15 square feet. Pretty easy. Now, this one says the volume of a room is 722 cubed feet. What is the length, width, and height if this room is a perfect cube? Now, if it's a perfect cube, you got to remember the length, the width, and the height, they're all going to be the same. Okay, so if I drew, I'll do the best I can to draw a cube right here. That's not too bad. We know that the length is going to be the same as the width, and since we don't know it right now, we'll just use a variable. And we also know the height would be the same. And to find volume, you're doing x times x times x, because that's the length times the width times the height. And how many x's are there? Well, that is x to the third. And that makes sense because if you think about that cubed feet, that means you're talking about cubed root. Okay? So when you create this equation, it's just x cubed equals 729. And to find your answer, you just cube root both sides. So you just cube root both sides. And that gives you x equals 9. So you know the length, width, and height of that room is going to be 9 feet. So you've got one more practice problem to do. Make sure you solve this by putting it in the area on the left side with your foldable. And when you are done, you can input your answer into Edpuzzle. Thanks.